Okay, question 22. We have this 9-mark question on stationary points, differentiation, drawing graphs. So let's dive into part A. So we're told that a curve has equation y equals x cubed plus x squared minus x, and it has a stationary point here. Find the coordinates of the other stationary point. So what kind of graph are we talking about here? Well, we're told that with this curve, and it's a cubic curve. So recall that a cubic graph can have two stationary points. So one of them is going to be here, that's the maximum point, and one of them is going to be here, that's going to be the minimum point. So we've been informed that one of these 2 points is this. I'm going to find the other one. So the way that we're going to find it is we're going to do differentiation on the original curve. Differentiating the original curves gives us the gradient function. And when the gradient function equals 0, that is when the stationary points emerge. See that gradient 0 here, and that's where the stationary points are. So let's find the derivative of our original. So we've got dy by dx equals 3x squared plus 2x minus 1. Now, if you don't know how to do differentiation yet, you need to look that up online or in your textbook. Okay, so we're going to set the derivative equal to 0, and then we're going to factorize this. 3x squared plus 2x minus 1. So if there's a 3x at the front and a 1 at the back, I'm pretty sure that one of the brackets is going to have a 3x here, and the other one's going to have an x, because, you know, what other way could I multiply two x's to get 3x squared? I'd probably be in decimal territory then, but they're not going to do that to us in a question like this. So it's probably 3x times x, and then I'm going to ask, okay, how do I get minus 1? Well, that's going to be positive 1 times minus 1. So the final question is, how do I get this plus 2x in the middle? Well, if I did 3x times positive 1, then I get positive 3x. And if I do x times negative 1, then I come up with positive 2x. So this is the factorization. Okay, so this corresponds to an x value of 1/3, and this corresponds to an x value of negative 1. Now, the 1/3 x value, that's our stationary point that we were given. So looking at the minus 1 x value, we're going to take this minus 1, we're going to plug it into the original equation, and that will give us the value of y. Okay, so y is equal to 1, and therefore the stationary point is at minus 1, 1. Okay, so that is part A. Part B, by sketching the graph same as above, determine whether the stationary point is a maximum or a minimum. Okay, so we've already determined that this is a cubic graph. So the shape is either going to be like this or like this. So we've got one stationary point. We've just discovered the other stationary point, minus 1, 1. And looking at the equation of the graph, I can see that the graph has no y-intercept value, i.e. the constant value after the variable terms. The y-intercept value is 0, and that means that the graph is going to pass through the origin. So I'm going to plot now the origin point. I'm also going to plot our two stationary points. So the first one, 1/3 minus 5/27, around here. So I'm just making a rough estimate of where that point is going to be. And the next one is minus 1, 1, and that's about here. Okay, so based on these 3 points, and the fact that the y goes through 0, the y-intercept goes through 0, which graph type am I going to choose? Well, to me it seems clear that it's this type here. And it looks like this. Okay, so that's the shape of the graph. That's the sketch. And we've been asked to determine whether the stationary point 1/3 minus 5/27 is maximum or minimum. Well, that's this one here. And since it is the lower of the two stationary points, then it must be a minimum, since it's down here. So this one's the minimum, and this one's the maximum. Okay, the equation has fewer than 3 solutions when it is equal to k. Find the range of possible values for k. All right, so what this is saying is that we're imagining that this equation can be equal to k, and when it is equal to k, that means there's less than 3 solutions. Now let's just cover what we mean by a solution. So the solutions are the points where if we took a y value, let's say y equals 3 or 4, then the point at which the y value intersects the curve, that's the solution at that given value, okay? So you can see here that if I drew a line here for the y value, there'll be one solution, and that's when it crosses the graph. So our question says, when there are fewer than 3 solutions, that's when we have our k value, and that's the values they want us to show the range of. So let's first find out when there are 3 solutions. So I can see straight away that when y equals 0, there are 3 solutions here. There's one solution here, there's one solution here, and there's one solution here. So there's 3 solutions in this area here. And it follows that there's also 3 solutions here, and all the way up to our stationary point, there's 3 solutions. Now, once we reach our stationary point, now can you notice that there are only 2 solutions, here and here. And once we get higher than our stationary point, well, there's only 1 solution, and that's all the way up this here, right? Each time there's only 1 solution. So 3 solutions starting from the stationary point here, and there's also 3 solutions up until this second stationary point here. So actually everything inside this range has 3 solutions, and everything outside of this range has fewer than 3 solutions. Similarly, down here, everything outside of this range, that's fewer than 3 solutions. Okay, so that's the range that we want. We want our k value to cover this yellow area. And that is equal to k greater than or equal to 1. Because that's the y coordinate of our stationary point, and also k less than or equal to -5/27.